In this short video, I want to talk about motor starters. Now, the one thing I want to make clear to everybody is that motor starters are primarily used in extremely heavy commercial equipment. I mean, we are talking past the point of the average rooftop, past the point of the average compressor. We're talking in extremely large units, centrifugal compressors, heavy motors, and it's going to be three-phase equipment. We do not see a lot of motor starters in single-phase equipment. Okay, a motor starter is basically a combination of an overload, some overload heaters, and the contactor, a triple pole contactor. Okay, L1, L2, L3 are my lines coming in. Then we have our motor, and then we have a heater and a scent that acts as a sensing element on current. Okay, you have your contacts, and then you have overload heaters and overload contacts. And where they're at, they're found here, down in the motor starter. And they're pretty easy to spot when you take a look at it. Okay, now what happens is basically the heater heats up based on the current flow. Okay, once the heater heats up and breaks the circuit, okay, it will force a small set of contacts to open, and then it opens the larger contacts. Okay, and again, this is just a little bit more showing you. Okay, so what we have is we basically have the internal components. Okay, opens a switch in the control circuit, which will then pop open the starter circuit. The whole point of this is that regardless of which leg gets an overload condition, you see here there's our heaters and our coil for our start circuit. Okay, once any one leg of your three-phase gets an overload condition, the entire contactor, all three legs will open. And this is extremely important because if we just had the overload on, let's say, terminal 3, like we see on a single-phase circuit, okay, it's going to take out L3, but it won't take out L1 and L2. So we have to make sure we're able to disconnect all three legs of our circuit at one time, and that's why we put the overload into the start circuit. So the overload contacts open, okay, and it's gonna basically open up the main contacts. So the motor starter, okay, again, it allows the motor to start with the higher current. But then once the motor's started, it's going to go ahead and it's going to reset it so that it only runs on a lower current. And that's what this is showing. Okay, so what we have is over time, our motor gets energized right down here in the bottom left corner. Okay, contacts close, we're going to have a pull-in current. That's basically our locked rotor amps, called a pull-in current. Once that pull-in current is done, we're going to decrease to what we consider a hold-in current. Okay, our hold-in current keeps that relay held, keeps the contactor held in until it's done with the call for cooling or whatever's going on. But our pull-in current, and now if this goes too high, it's going to open up the heaters and pop open. If our hold-in current goes way too low also, it's going to open up our contacts. So we have a pull-in current and a hold-in current. That's why it's a motor starter and protector. And that's basically how easy the things are. Now, going back to one of the pictures of this, you have some replaceable parts here. The heaters are replaceable. The contacts tips, okay, the contacts are actually replaceable in here. So these are rebuildable components. That whole coil is replaceable. These things are expensive, they're heavy, and you don't just toss them and replace them, you do rebuild them. What you need to know is that you'll have to let the parts house know the voltage, the amperage, and there's usually a model number and a manufacturer stamped on these. The supply house is going to have to know that as well.